Oh, what happened to serving backpacks?
They're too small.
Okay, I'm not joining you guys anymore. That's a deal breaker. I think we can start. Well, thanks everyone for coming tonight. Despite I think there is an origin or some sort of sport that people follow. I didn't know, sorry. So scheduled on the same night. But thanks for coming to the Brisbane Serverless Meetup. That's our last edition in this office. So next time the Mantle Group is moving to the city. So the next time we're going to have it in the new office. Today we have two speakers. We have Stanley Zhang from Mantle Group and we have Greg Luxford from Siva. They're going to present a few exciting topics. I think the first one will be on the SFTP, how we can build SFTP server using serverless technologies from AWS and make it configurable. So it will scale and be really cost effective. And Greg is going to present his AWS Summit topic that I think you're presenting next week in Sydney. So you're getting this for free. Otherwise, you would need to register and pay. And yeah, so that's going to be on the AWS config and compliance automation. So quite a big topic, especially for large enterprises. We also streaming this online on YouTube, so you might be able to rewatch it later if you need to, or if you can't see, or if you want to probably have a look at the slides again. You can do it on YouTube. Otherwise, just reach out on AWS Meetup page. I think we have it on the screen. Put a note in the comments if you want to get a copy or anything like that, or if you want to get in touch. So I think probably going to ask Stanley to come here and present his first topic. That's right.
I want everyone to hear me, actually. All right. So yeah, thanks, Ilya. Good evening, everyone. Welcome to the Serverless Meetup for tonight's session. So a brief introduction of myself first. I'm Stanley Zhang, and I am the senior consultant from Mantle Group, AWS capability. And I joined Mantle Group about 2.5 years ago. So yes, I've been working with clients in sectors like banking, media, and also energy, financial service, and supply chain, etc. But my main focus is in AWS DevOps. So a bit of security assessment involved as well. Platform security uplift, what else? Database migration and a bit of a containerization as well. So that's me. And tonight, for this session, our topic is about building the serverless SFTP solution. So let's make a start. In terms of agenda, that we will first have a look at, so from the market, what are the available SFTP products out there, and what are the types of SFTP products. So there are server products, some are open source, commercial, and some are managed services. We'll just do a comparison of what are their main features versus limitations. And with that context set, we'll then dive into our serverless SFTP solution, just with a more deep dive and go through the details. Cool. All right, so from the market, if you search for SFTP products, you'll probably find like hundreds of them, various different features of each. But basically, there are, for the SFTP server products, there are two main types. So you get, like from the very beginning, there are those open source versions that you don't pay anything for it. You basically grab it and install in your own infrastructure, either on-prem or cloud. There are some Linux versions, some Windows. But the limitation is you have to do all the installation and the setup by yourself, which means that you have to manage your infrastructure, set up the OS, do the patches, set up the user directory, manage the storage, and also, as you know, that for the file transfer, the security requirement is usually pretty high, so you have to make sure that you meet all the security standards, and you manage the backup restore, which is another important part for any file and data related transactions. You manage your own infrastructure, which means there's a lack of scalability and high availability because it's just a single machine. And it's also missing a bit of enterprise features. From that, you then get another type, which some commercial products emerged, which are a bit richer in features. And you can see that those examples, most of them are Windows-based. That's mainly because those add-on features, they provide you like a Windows GUI-based interface. They're more user-friendly. Some advanced access controls, and that give you integrated security and compliance features, make it easier to set up compared to the command line scripts. They give you professional support, multiple protocols, etc. So basically more features compared to the open source versions, but it still has its limitations. So if we look at some of the limitation here, because it's still a software-based SFTP server that you install on your own infrastructure, so all those operation overhead still exist. You still need to set up all that by yourself. And of course, because of the added features, it becomes more expensive. So you pay for the price, and those pricing licensing model usually come with like a fixed term license that you pay either monthly or yearly. Different vendors have different price models, but generally speaking that you're locked into a price based on the package that you choose. You can pay by monthly prices or yearly prices, depends on the package you choose. And like I said earlier, there are mostly Windows-based and with limited customization. So then with the introduction of all the managed services and the cloud SaaS products, SFTP solution is one of them that actually some vendors start to provide managed services. So compared to the software-based, basically managed service, they include a hosted and a managed solution. They're all provided by the vendor, so you don't need to worry about anything about the infrastructure, patching your server, upgrade your server version, etc. Don't need to worry about any of that. That gives you the benefit of a quick setup and with a secure data transfer, a secure platform, and with the minimal operation overhead. So that's the main benefit it provides. Examples like files.com and goanywhere.com, etc. That's like a couple of popular examples. Main benefit being no infrastructure to manage. And the price model has also changed to like a subscription based with pay as you go. You're not locked in for like an annual price, and you can, if you want to use that for 3 months, then 3 months subscription. However, most of these retail managed solutions, they solve some of the problems. However, they still have its limitations. So one of the biggest one is it's very high cost because compared to the software ones, it has included managing the infrastructure for you, so it's not hard to imagine that it's going to charge you more based on all those services it offered to you. And also is the limited customization. Because it's a retail facing like to the market, it can't possibly customize based on every single use case to build exactly the features you need. So you usually give you like a 3 or 4 different packages to choose from, and you have to pick one of them, and even you only use 2 or 3 out of 10 features from that package, you still pay for the entire package. So some people will start to wonder, is there a managed solution that you can customize based on exactly what your business needs? You only pay for what you use, and the solution gives you a very cost-effective pricing. And that's the main service that we want to cover tonight, which is using AWS Transfer Family to build a managed SFTP solution. So on this slide, I just first want to give a quick overview of what AWS Transfer Family is. So I'm not sure how many of us have heard or used Transfer Family before. That's good. See some hands. I would say this is not a very wide use case, like among all the AWS services. So it's kind of a bit narrow use case, but it's fully serverless and being quite useful just for its own use case. Basically, it's a fully managed cloud native service that enable you to do the secure file transfer over all those different protocols, SFTP, FTPS, etc., in and out of the S3 or EFS. So those are the storage in the back end, is where the data or files actually stores. And most importantly, without need to provision or manage any servers. So basically, you get exposed with an endpoint. And the endpoint is the only thing you interact with. All right. So if you look at the diagram in the screenshot down the bottom here, so that is a very simple and standard representation of the infrastructure for the transfer family. So in the AWS cloud, you set up the STP service, basically behind the scenes a server. And as a client outside of the AWS network, you use any SSH client or SFTP client, you connect to the endpoint. And the endpoint of the SFTP that interact with the backend storage, in this case, is the S3 buckets. So that just plays as a middle tier to exchange files, like between clients and the cloud storage behind the scene. So that's a very standard setup of a pure transfer family server in the AWS cloud. So if you look at the key features here, apart from supporting multiple protocols here, serverless, no need to manage any server or patching. And because it lives in the AWS ecosystem, that it has native integration with a lot of the other services. But here is because the backend is either S3 or EFS. So that's a native integration. Apart from that, also integration with the rest of the services for building add-on features, which we'll talk about a little bit later. Encryption, that's all included as a standard. So we have the KMS keys to enforce the encryption at rest for the data and the files stored in the cloud storage. TLS is enforced for encryption in transit, so that's all the default settings. You can use the IAM-based access control to do the fine-grained access control for the user. Like even for the bucket access, for even the bucket folder access, it can all be defined based on the need. VPC can be used to provision, you can provision the service inside of VPC for some added features like IP whitelisting, which again, I'll talk a little bit later in the slides. So main benefit, I think I mentioned most of this already in the features. High customization, low maintenance, meets the security compliance, and the high availability, fault tolerance, scalability, that's all the features that brings to you from the cloud-based infrastructure. So after that overview, I want to give you some like a quick and some examples about how the pricing works. So when I say that it's a cost-effective solution, how does the costing works? I want to use a couple of examples to calculate the cost so that you can compare with the other products out there in the market. Serverless products, you don't need to worry about any charging by per server or how big the server is. You only get exposed with an endpoint. So let's say if you use one of the protocols here, for example SFTP as an example, you set up one endpoint, and the endpoint charge you 30 cents US cents per hour, 216 per month equivalent, and that charge is a fixed price, regardless of the activity, which means whether you use it or not, if you use that very heavily or not use it at all, you charge 216 bucks per month. Plus that, you get charged the data uploads and downloads, which is the standard data transfer cost on top. Web app is a separate app, which I'll talk a little bit later, but just want to quickly mention the price here. If you want to put a web app in front for the access to the S3 buckets, it's another price that you pay, slightly more expensive, and that basically gives you up to 250 unique sessions per 5 minutes sessions. Data upload and download is not charged, so that's all included as a different option to access objects back in the S3 buckets. So the first price example here, which is probably a small, like a standard use case. You use one protocol, you set up 20 users and you only do download, like a 1 gigabyte a day, and with a backend storage of 100 gig in the S3 buckets. So how does the pricing work for that? You get charged for a fixed amount, like I mentioned, $216, plus based on the usage, which is a quite small fraction of the cost here for data transfer and the backend storage. So altogether, you'll probably find like 98% of the cost is actually the fixed cost, right? The usage is just so minor for the very slim usage. Then let's look at a slightly heavier usage here. Still a single endpoint get used, but you download more each day and with a bigger storage in the back in the S3 bucket. Endpoint cost is the same. Upload and downloads that cost you slightly more, with the storage cost you more as well. That end up being around 300 bucks. So even the usage is around like a 60 bucks, 70, 80 bucks, plus the fixed amount, you end up paying 300. So that's like the professional usage in like a mid-sized companies that you have more users. It's the typical usage like that. Also worth mentioning here that they do not charge you for any user setup. So whether you set up 10 users or 100 users, the same. They don't charge you based on the user count. It's typically just the endpoint plus the data transfer costs, plus storage. The third example is probably like an enterprise customer with a heavy usage, where we have multiple endpoints, right? So you can use different protocols. So in this case, we set up 2 endpoints. Each have 500 users, and they do both upload and download, 100 gigabyte and 50 gigabyte for download, storage 20 terabytes. So following the same algorithm, we calculate that. You basically add up the cost. The endpoint cost has doubled. Transfer cost set up per endpoint, so altogether add up to 1,300, around that. So how does that compare to the cost that we mentioned briefly earlier? So these are the examples from like a commercial products. Just be aware that those prices has not included the infrastructure cost yet. So this is only the software level cost. And if you add the underlying infrastructure, you add a basic server, that's easily another 300 bucks on top. You set up multiple servers, that could be even more. So with that comparison, you can see that basic transfer family managed service setup it's just a fraction of the cost if you get that from the commercial. Plus, you don't need to manage everything. Is there any questions or any question before we move on to the more technical section about the customizations? It's purely on the pricing.
How does the pricing compare with something like storage gateway, for example?
So you can install. So you're talking about like the appliance that you can purchase from the marketplace and quickly set up a SFTP server?
You don't have to set it up from marketplace. So you can use storage gateway in front of S3 to present lots of different file formats.
Yep.
So you can have like instead of using SFTP, you can use like SCP and things like that.
Yep.
With that solution.
Yeah,
I'm just curious about what that sort of pricing model might look like.
Yeah, I think that's probably similar. I understand the setup for that. The pricing wise, I think it can be a little more expensive because it's very similar to the web app option here, which I will talk in the later slides. It basically give you like a web-based user interface so that you can directly interact with the objects in the S3 buckets, upload, download. I'll give you price examples later on when we talk about the web app. All right, cool. Let's move on to the customizations. Another big advantage of the transfer family, because it lives in the AWS ecosystem, that so many integrations with other services, that we can add the extra features on top of the transfer family so the list of the customizations that we have built in one of our internal projects, right? So this is the list that we have done. So some more fine-grained access controls, IP whitelisting, client-side encryption, because it's a good use case, widely used use case that you need to exchange files with the external parties. Like, let's say if you're a retail business, you probably have many vendors that they outside your network. How do you securely exchange files with them with their client-provided encryption method? So we have a solution to cater for that. File integrity validation. How do we ensure that the files in transit do not get corrupted or modified? So we have a solution to enforce the integration. So integrity of the file. Malware protection and file retention policy from the storage S3 bucket. So we have solution for all this. So now I want to quickly demonstrate an architecture of an internal project that we built last year. That just with all these added features to the transfer family. So, sorry, the font is a little bit small. Don't worry if you can't read it. I'll just quickly step you through both the ingress and the egress flow. So basically, what we have provisioned in this project is the transfer family here. The service endpoint is the central point of everything. Everything connects to that. And we have provisioned that inside the VPC. The reason we put that in the VPC is because we want to use the security group for the IP whitelisting purpose. So IP whitelisting, you set up the transfer family with an elastic IP because it's a public facing for the external clients that need a elastic IP address. So, and security group attached to that, you basically can set all the security group rules to only allow the client from allowed IPs to connect. Let's imagine that you have this public-facing SFTP service, only your approved vendors can connect to you and exchange files. So security-wise, that's pretty basic for the whitelisting. So that's one of the features which is implemented with the security group. In terms of the high availability and the fault tolerance, you probably have noticed that for the subnet, we choose to deploy it in 2 AZs. What actually happened behind the scene is, as the standard deployment transfer family is one server that you will randomly get deployed to one of the AZs. However, giving it a minimum of 2 AZs gives you the ability that in the event of any AZ failure, the transfer family as a service can automatically fail over, like between the AZs. So that's all managed by the service that, from user's point of view, the endpoint will stay online and there's no interruption of the service.
Sorry, just on that, does transfer family manage the Route 53 endpoint for it? Is that how that works for automatic failover?
It's all managed behind the scene. It depends on if you want to supply like a custom domain. You can support that. I think by the default, if you use the default endpoint, behind the scene is probably using Route 53. But that's all managed. It's just the failover. It failovers, but for this deployments, because you can just deploy one server behind the scene, but in the failover, there's probably like a very small outage where it creates the new server and the failover to the other server, which is probably a short outage out there. But the file transfer is not like that demanding on the continuous service online, so like a short outage probably not having a big impact, and you file transfers, if you fail or get pending, can just retry and eventually succeed. But I think it's a good point. I think behind the scene, Route 53 could be used to manage the failover. AWS never tell you how this is managed behind the scene, but
It just represents as like one single endpoint. They're not separate endpoints across the 2 AZs.
I think it's the single endpoints that the instance just gets switched over behind, but the endpoint never change, because you never want to change the endpoint on the client side, which you may end up updating 100 customers, which is a pain. Yeah. Okay. Okay. So I would like to explain like the typical ingress and the egress workflow here. So let's say for ingress, I mean the upload. So as your client from outside of your network, you want to upload a file into your backend S3 buckets. So we set up the upload user here. Basically, you can use any SSH client. So in our example, we can use the FileZilla as the SFTP client with the SSH key configured. So you connect through the internet gateway, obviously being allowed IP from the whitelisting. It connects to the transfer family here. Sorry, I'll just switch over to here. And then the role has been configured for the user that connects you to the relevant bucket that's provisioned for you. So we have this upload bucket, which is like a staging bucket, right? The reason why we have 2 buckets here, so the staging bucket will accept the file. But because we use the client-side encryption, the file that the client uploaded is an encrypted file. So file encryption was implemented with a GPG key pair. So you basically have a private key and a public key. The client will supply that to you, and you create 2 secrets in the secret manager. You put the public key in one secret, private key in the other. And in the typical ingress workflow, once the encrypted file reaches the upload bucket, that will trigger the event notification when the new files arrived. event notification will trigger the ingress Lambda function. That Lambda function does a couple of things. You will first retrieve the private key from the secret manager based on the role defined for the Lambda execution role. And then you will decrypt the file based on the key, the private key, and then copy the file into the raw storage bucket here. The raw storage bucket is the final bucket that includes the decrypted file, and you as the vendor actually can access the file directly from there. So that's the typical ingress flow, all the way from the client, upload, decrypt, copy the file, eventually reach here. So that's a typical workflow of how using the client-side encryption GPG key works. And then let's look at the opposite, the egress. So that's when you as a vendor, you want to send some files to your client. You want to ensure that the file get encrypted before get sending over to your client. So what happened here is there's an export bucket where you dump all those raw files, which are unencrypted files, directly into the export buckets. Forgot to mention, all those buckets are protected by the KMS keys, which enforce the encryption at rest. So once you drop the file into the export buckets, immediately trigger another event notification from the buckets. It triggers the egress Lambda function. And this function does a bit different compared to the ingress. This does a couple of extra things here. You first will retrieve the public key from the secret, because when you're encrypting a file, you just need the public key. You encrypt the file. You can also optionally create a checksum for the file. So it's a separate file just for the checksum information. Eventually, it's two files get sent to the client. The client uses the checksum file to validate if my file has been touched during the transition, right? Just to validate the integrity of the file. So that's another feature here, that if you want to enforce the file integrity check, the Lambda function can be enabled to do that checking. So once the file is encrypted, create a checksum file, two files get copied into the download bucket. So here it is another staging bucket that stores the encrypted file and the checksum. That get forwarded and exposed to the transfer family to the download user via the internet gateway. What the download user sees in their SFTP client, they will see on the server I have two files. I just can download and drag them to my local client. Once they download the file, they can use their own key to decrypt the file. That ensures the file get encrypted during the transit between the vendor and the final client. So,
if you're using SFTP, why do you need to encrypt it before you send it?
That's a client requirement.
I might chip in. So this kind of architecture been implemented, I think, twice. And one of them was a large payment provider that exchanges data within banks. And they have restrictions, a lot of rules around PCI DSS compliance. Essentially, I think this solution could be deployed to different AWS accounts. So your SFTP upload download buckets are basically your demilitarized account where you can store viruses, movies, whatever. So because it's all in encrypted form. But the clients, for example, if banks exchange data, you'll be surprised how much data is still exchanged via SFTP. And that's the requirement from the bank. They're like, okay, we can only accept SFTP transfer. But then how do they know that what they accept is valid? And that's why they use checksum validation, they use encryption. I think maybe the only comment that sometimes they will only give you, and I think they should only give you public key. So you only send public key to the other party. So if you receive files, you generate private and public key, but you keep private in your AWS account. You send public to the client. restrictions around IP whitelisting and a bunch of other rules.
Yeah, so basically the client requirement plus what you offer as encryption in transit. Absolutely, SFTP from the transfer family, they give you the default feature like enforcing the encryption in transit, but plus the client encryption in place that meets certain client requirement when they're seeing security being a big requirement from their point of view.
There's a simpler solution for less rigorous requirements in storage browser for S3. So that's a new
Yes.
service.
Yeah, it is a new service that basically that connects directly to the S3 behind the scene.
Into your web apps, and it gives your web apps
It's a slightly different use case, isn't it? Like it's not
it's a different use case.
it's a different protocol.
Yeah.
The way I see it, actually, it's to keep it here. So you can deploy it on top of that raw storage. So instead of exposing those buckets to the users, right, you can have like a web apps or something like that. So if you have like internal staff members that should be able to come and browse the unencrypted files, then I think it could be a good use case.
Yep. Yeah. So that use case is probably more for like a non-technical users. So like if a company doesn't have a DevOps team or IT user to set it up for you, you can basically integrate that as part of your like an Entra ID or Okta authentication. You log in with your SSO federated user, and that just becomes one of the app in your app list. Yeah. So that's slightly different use case. So how do we configure when we talk about so much about customization? So in this project, how do we customize the configurations and make sure all those configurations get deployed, defined and deployed separately on the client level, for the transfer family, etc. So in the project, we use this YAML file, which have all the attribute defined. So this is a configuration-driven projects. So all the main stacks stay the same, but it will deploy different resources. Depends on the how each client and the transfer family stack is configured. So some typical examples here is like, so when you create a VPC, that how many AZs do you want to create? What's the protocol that you want to use for the transfer family? Do you want one or more, multiple? Security policies, and do you want to use the custom host name, etc. That all can be customized here. And also that for each client, say if you set up 20 clients, right? Each client has different requirements. So I only want to do download. You probably want to do both upload and download. Your IP whitelisting from different IPs. I'm a bit different. I don't need a white. So, and you need different encrypted file extensions, different checksum algorithm. That can all be defined on the client level. So if you look at this section here, that's the typical section that you define for each client. Client name, do you want any IPs in your whitelist? What's the accepted encryption file extensions? So like a GPG and other things. So the Lambda function will do the encrypt and decrypt based on the extensions you provide. The checksum algorithm here, you generates the checksum file based on the algorithm you specified here. Do you only want to create like a upload? So like in this case, they only need a download user, no need for upload user, where compared to this user, they need both upload and download. And what's the key that you supply? So based on this configuration, you define everything in here for the full customization. Once it's all defined, how do you deploy it? So the deployment, this is a project that we build in Python, CDK projects. Basically break down into multiple stacks here. So you create your VPC and the resources in the VPC, subnets, internet gateway, security group, etc. The Lambda stack will create the Lambda functions, KMS keys, and creates the secret, and then you put your public key in the secret. Then the transfer family stack eventually creates the main transfer family server, the users, roles, and the whitelisted IPs. Once that's all configuration done, you basically just bootstrap and do the CDK deploy to create the entire stack. Then everything will be created according to the configuration that you set up in the configuration file. And this architecture also allows you to make changes. Like, let's say if you create initially with 20 users, later on you say, oh, I have another 10 users to add. Some people has left the company, I need to remove some users. What you do is you just go back to tweak those configurations. You remove some users, add some new users, and run the CDK deploy. That will do all the modifications, add and drop for you. So one of the benefits of CDK deploy, it creates the CloudFormation templates behind the scene, and it will figure out automatically what needs to create or drop or modify. Any questions here? Just quick pause here. Okay, cool. Forgot to mention that screenshot is just a FileZilla client. That's typically, if you want to use your local client, like how you interact with the transfer family service. So these are the files that you see on the server, and then you can drag and drop and move the files between client and server. I think lastly here that the web app. So I think it's, I'll just quickly intro about this web app. It's a new service from AWS. I think that was just announced late last year from the reInvent. So AWS called it the turnkey solution, which is basically you don't need to do anything. That you don't even need to set up your client, right? So it's a web app that you use your browser to log in. I think maybe some of you might heard the storage browser for Amazon S3. So I think it was announced in the same year, a bit earlier. It's a web app, like a front end from the browser that lets you interact with the S3 bucket in backend directly, that you can upload, download, and file transactions directly from the browser. So what Transfer Family did is they took the core functionalities and make their own version to suit for the file exchange from, like, as part of the product of the Transfer Family. So it's a browser-based user interface, very similar to storage browser. So it's suitable for non-technical user. You don't want to set up your SFTP client locally. You can use the browser. And one of the key feature here is Transfer Family has integrated more IDPs in the list for the native integration. So like I said earlier, that if you use Entra ID from your organization, that it can, Transfer Family, the web app can just become another app in your list from your web, the application portal. If anyone is interested about this, actually there is a reInvent video that you can watch that for more detailed information. But I think the key takeaway here is it's a more expensive tool for some added value, right? So they don't call it turnkey solution for no reason. So that's a little bit about the web app. Finally, as a summary here, I think we talk about the using AWS Transfer Family with the customization. Some of the key benefit here is a cost-effective solution. So why you pay more from the market vendors for those retail products when you can build your own for cheaper cost, and you can do full customizations with all the integrations with other AWS services. It has pretty flexible price model, full customization based on your requirements, no maintenance unless you want to tweak some configurations. Otherwise, you can just set up and forget. So everything that's managed behind the scene for you. You can choose either use transfer family or the web app. That's typically based on the end user type or the budget. But because the web app is slightly more expensive and catered for different group of users. That's pretty much all I want to cover today for the AWS transfer family and the serverless solution. So just wonder if there are any final questions before we wrap up. Cool. Thank you very much. That's it for the session. Thank you.
So we've got some food just waiting here on the table, I think, before Greg presents another topic. Just a quick announcement. There was a book called Cloud Native Anti-Patterns released a few months ago. So Alan Buckley, one of our Brisbane-based AWS user group lead, is one of the authors, and also Owen Živich. I think you remember him. He comes here quite often from Sydney, so he's also from Mental Group. So if you're interested, I think I'll just leave it here so you can take a look. If you want to look at some of the diagrams here, I'm not sure how relevant they are, but I feel like with the development of Gen AI, agentic coding, and all that stuff, maybe like a pure programming is becoming less important, and following some good patterns and making some good architectural decisions becomes more important. So please take a look. And also another announcement, we have AWS coming today, coming to Brisbane, I think for the first time. I don't remember, did it ever happen to Brisbane? So it's going to happen on the 15th of August. There is a website, I think it's called AWS Community Day, AUS.com. So that's the AWS Community Day's website. So keep an eye on it, and maybe book a date in your calendars. Probably an event that you don't want to miss. All right, let's grab some food.
Hungry.
Oh, you have your slides just from the summit, right?
Yeah,
Awesome.
the same one I sent you.
So you guys can pretend that you're not here, but you're in Sydney. If you're not living today, you live the future.
Yeah. And if you're in Sydney on the 4th,
Don't come to this because you're already.
come along and heckle. Put me under the real pressure.
All right, so
All right.
what's here, Greg?
So AWS Sydney Summit, 4th and 5th of June. Free to come to. If you haven't registered, think about it. All of this is on demand as well. So I'm presenting on the my topic that I'll talk about today. This is actually part of the, sorry, I'm just going to reset my timer. So this will be presented at the Developer Lounge as a lightning talk. So today we're going to be talking about level 300 presentation here on automating compliance using AWS Systems Manager, automation documents, and AWS config. A little bit about me. I'm an AWS ambassador, AWS community builder, and I'm a principal consultant for a consultancy called Civo. I've got a few certifications, as you can see, and I've even done a demo around Amazon Q CLI more recently. So today what we're going to cover is a problem overview, a little bit of what it is that we're actually trying to solve. Finally, we go through a little bit of an overview around AWS organizations, AWS Systems Manager, AWS config, and a little bit of an overview of a practical implementation of this. So first of all, we have a problem, and that is, how do I ensure that I remain compliant to my governance? So governance, thinking about governance as a whole, is actually around establishing the foundation for the ethical and responsible business practices. So it's the intent. Compliance ensures that the organization's actions actually align with the governance and with that intent. They're mutually needed. And the question is, how do I ensure that I remain compliant? So we need to use a combination of controls. Some are detective controls, because I need to find what's not compliant. I need preventative controls to prevent things that aren't compliant from moving from that state. I need proactive controls. I need to report. I need to measure. And I also need to automate. So AWS organizations, a little bit of an overview here, is a series of controls that they have around your organizations. So an organization structure looks after essentially your management account and all of your sub-accounts that exist for different reasons. And it provides central account management. So this includes organizational units and accounts management. It also looks after centralized billing and setting the delegated administrator. So that's for AWS services that you wish to control, and you want to do that from a safe place as opposed to configuring them from the management account. So AWS organizational units. So these are simply containers for accounts to reside in your organizational structure. Think of them as a folder structure on your hard drive, for example. We have service control policies. We have things like inheritance. So we can apply a control at one level and it's inherited amongst the other organizational unit structures. The root account is unaffected by SCPs or service control policies, and it represents a logical hierarchical structure. We also have AWS Systems Manager, and this is a comprehensive set of tools, multiple services combined together to formulate enhanced visibility, boosting efficiency with automation, and also simplifying node management. We can look at things like runbooks, security patching, and we can look at hybrid activation, so that's using systems that sit outside of AWS. AWS config. So the purpose of AWS config is to record the state of infrastructure and services and things that you're using inside your AWS account. It's all of those resources. It's used for security analysis. So we can look at, are we compliant or not? Very black and white. But we can use it for auditing and compliance purposes. So we can maintain compliance and we can look at measuring that compliance. It has a lot of integrations in with third-party tools as well. as well as AWS services, including Systems Manager and also Security Hub. It looks at resource administration. So how do you actually maintain and configure those resources? And also does resource management. So we can look at the state and actually manage that state. This is all part of a bigger ecosystem, and that is the secure landing zone. So when we think about compliance and we think about this at scale, we're talking about regulated industries, we're talking about lots of different customers and different demographics. However, they all have one thing in common, and that is they want to be secure. So whether that's secure against a particular compliance framework or whether that's secure in general. So let's walk through a practical example. In this case, we wanted to automate VPC flow logs. You may be asking, well, what is VPC flow logs? So we use VPC flow logs for a variety of reasons, mainly around understanding the flow of traffic throughout our virtual private clouds. We also use this for diagnosing restrictive security groups as well. So it can be used as a tool to identify the traffic that's being dropped, for example, by a specific security group. It's just an arsenal of tools that you can use, and this just happens to be one of those tools. It's also used in compliance, where in some regulatory compliance structures, it's a must-have to have end-to-end tracing of where your traffic's actually going throughout your infrastructure. It's part of this AWS Security Foundational Best Practices. So these are enabled by default when you use things like Security Hub. It integrates in those, or it can be used for third-party tools, so they can actually manage those flow logs or see those flow logs and do things with them. And as part of those regulatory compliance requirements. So let's look at a problem. So when we talk about a problem, it's generally good to write a statement about what that problem is so that you're solving something towards that statement. In this case, I want to store VPC flow logs centrally in an S3 bucket, and I want to put that into my log archive account. So I want to put it into a place where all my other logs live. I want to ensure that all the VPC flow logs are enabled on all my VPCs in all of my accounts. And I want to ensure that VPC flow logs cannot be turned off because I need to maintain that state for compliance purposes. I want to automatically configure VPC flow logs on all new and existing VPCs. So it's not just from here on, I also need to think about my existing resources. So the key takeaways from this problem are, I need to look at all VPCs, I've got to consider all my accounts, I need to centralize my storage, I need to prevent those changes, and I want to automate that process. So some of the challenges that I might face with this, I need to check the status of VPC flow logs. I need to understand where they're at. I need a central bucket that needs access from all accounts. So this talks about cross-account traffic. Logic is needed with error handling. So I have to consider that, well, if VPC flow logs are not enabled, I first need to enable them. And then I need to set the destination to the bucket that I want to send those flow logs to. And if flow logs are disabled, I need to enable those VPC flow logs and then set the destination. So I have to think about all of the various states that could exist throughout my account structure. And this could be super important when thinking about mergers and acquisitions as an example. I need to have those preventative controls to prevent disabling VPC flow logs. So in this practical example, we have to consider using some tooling. One of those things is an S3 access policy. So I need to apply that to my S3 bucket. I need to enable VPC flow logs and centralize that bucket. I must have a config rule, so I can use AWS config to look at the state of where things are at with my VPCs. I need to use Systems Manager automation documents because why do I have to write that from scratch when it's already pre-done for me? I need to leverage off Lambda. So Lambda is critical to this infrastructure solution because I need to deploy Lambda functions to carry out the work on my behalf. And they are consumers of the Systems Manager automation documents. I need to leverage organizations because I need to target my accounts in my organizational structure. So I need to specifically target organizational units and different structures. Finally, if I want to prevent access and changing of that state, I need to leverage off service control policies, again, an organizational function. And of course, I want to automate the deployment of this. So in this case, this was a CloudFormation stack set. So we use stack sets to deploy CloudFormation stacks across multiple destinations, multiple accounts. And an overview of the practical example that I'm talking about here relies upon all of those foundational topics that we just covered. Together, this formulates organizations, CloudFormation stack sets. That stack set is deployed to an OU target. I leverage service control policies to prevent turning off VPC flow logs. This deploys the CloudFormation stack set to all of my member accounts where my VPCs actually reside. It leverages an AWS config rule to measure whether VPC flow logs is turned on or off. And Lambda is key. So Lambda runs the Systems Manager automation document and applies the changes to my VPCs on my behalf. It then sends those logs to my central bucket, which is protected by the S3 access policy. So only my organization structures can send those VPC flow logs to that central account. So let's recap on whether we're meeting those requirements that we set out for. Does this cover all my VPCs? Yes. Does this target all of my AWS accounts? Yes. We centralized the storage, we prevented changes through the service control policy which we applied, and we automated the process end to end. If you'd like to know more, please visit our website for Civo. And we actually have some open roles at the moment for senior data engineers. Finally, sign up with an AWS Builder ID. This will open your world to a large number of opportunities within AWS's ecosystem, including the Community Builder program, as well as other benefits such as Amazon Q CLI. Create a free account so that you can start playing with these solutions, and leverage Skill Builder for those on-demand courses. Thank you, and I wish you all a lovely day.
We don't have a mobile app, so ignore.
That's all right. That's for the, yeah.
Just a quick question on the cost.
Yes.
How much does it cost to implement all of this?
Yeah, so the cost varies, and the reason I say this, and I realise I didn't actually cover the extra content that I wanted to cover. I did present this at the Brisbane user group, by the way, and I went well over time. So I've been scaling back everything frantically to try and keep in time, and so yeah, I've breezed over a little bit. So the whole idea, sorry, if I actually just go back to the concept of this solution, the concept of this solution can be applied to many applications. That includes things like default security group removal. So if I want to remove all my default security groups and prevent someone from using that, which allows open inbound connection for anywhere by default, these are things that I could use this particular pattern for to achieve, including point-in-time recovery for DynamoDB is another example. Enabling RDS instance deletion protection, and enforcing S3 encryption. So these are all sort of things that you can use this pattern for. So sorry, just to go back to your question about the cost, it is a typical IT answer of it depends. And the reason for that is it depends on how many rules you actually have enabled and also how often they're being evaluated. So, for example, Control Tower, when it deploys AWS config for you against all of your accounts, the default behavior is to do continuous recording. So the cost actually varies based on the number of resources you actually have in your organization at the time. And so each individual resource that's being evaluated against the rule comes at a cost. And that cost is multiplied by how often it's changed as well, and how often it's actually being checked. So some of the things that we can do to minimize that cost is to set the rule evaluation behavior to periodic. And you can set that to various increments. So I believe it's 1 hour, 3 hours, 6 hours, 12 and 24. So yeah, it is very much an it depends. In this particular case, the rule that we deployed, we set to periodic to do every 24 hours. The idea being that that's the highest amount of time that I can actually set it to, but also how often am I creating VPCs? Far less often than other resources. So yeah, it's a combination.
I think it's more around, let's say, if you have not a enterprise grade organization, it's like a small to medium size.
Yeah.
Obviously, something like S3 bucket is pretty cheap.
Yeah.
And if you enable the config that checks the encryption on the S3 bucket every hour,
yeah, the costs add up.
do you think
Yeah.
this could become more expensive than S3 itself?
It can, yes. And the reason I'm mentioning these, they're simply just examples of what you can do. There's over 200 automation documents within Systems Manager, right? So I could stand here all night talking about all the various ones. I don't know them off the top of my head, but certainly they're just sort of targeted things that you could potentially use it for. S3 encryption is probably not the best one, granted. Any other questions? No? Awesome. Well, I hope to see you at Sydney Summit, and if not, you've just got a free preview of me failing miserably. So thank you.
If you come to the AWS Summit, there will be many people like Rick and many presentations.
Yeah, that's right. That's right.
Yeah, thank you so much.
Awesome.
I think thanks everyone for coming. Probably can stay around for another let's say till it's pretty late, but let's say another maybe 10-15 minutes. And as I said, it's probably our last meetup in this office, which is a bit sad. I think it's been a nice place. Next time we'll see you in the city. When the next meetup is going to be organized, I think it's still quite a big question mark. I'm expecting a second child in July, so I'll be away for, I don't know, a few years. But I think with the AWS community day, we'll see if we can maybe arrange some sort of event. I've been thinking about maybe hosting a roundtable just the night before the community day, where we can maybe get someone from the industry and just discuss some of the challenges that we're facing in the serverless land, but also probably a little bit broader with, Gen AI transforming the market and how it's going to impact all of us. So yes, so stay tuned. If you haven't signed up to the meetup page, please do. It's Brisbane Serverless Meetup. And yeah, I forgot to mention that it's been sponsored by Mentor Group. I think you all know. If you want to join, scan the QR code. Maybe a few of you